Hi guys, welcome again to Simplified RSA, the guys who makes it looks easy. As I promised last time that we will do this question here. This is the question that we'll be looking at today. And just to go straight to the question, the selected question is question 4. So it reads, two cars, A and B, are moving at a speed of 15 meters per second and 30 meters per second in the same direction. They are side by side when both drivers observe an obstruction ahead of them, as shown in the diagram below. So there's the obstruction, that black Chnge thing. We don't know if it's an accident or it could be some chickens crossing the road. We don't know, but then that's an obstruction that happened there. But then if you look on top of car A, we have the speed of car A and we have the speed of car B represented by the arrow on top of car B, showing we are working with a vector, or we are working with vectors rather. It goes on and say both drivers apply their brakes and accelerate at minus 4.5 meters per second squared until both cars come to rest. They want us to ignore the reaction time of the drivers. And then question 4.1, we should define the term acceleration in weights. This one is the simplest one because defining the term acceleration, normally in physics, the equation themselves tend to give out the definition of the variables. This is what I'm saying. Look at it like this. Already you know by now the basic equation for acceleration. So from the formula for acceleration itself, the formula states that acceleration is change in velocity over the change in time. Hence, the definition for acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. Writing that in words, you get your 2 marks. That's how you answer 4.1. Now, moving along to 4.2. 4.2.1, they want us to calculate the time it takes car A to come to rest, meaning it takes car A to stop. Before we do that, or rather before we choose our equation from the equations of motions, we have to at least show on a small data, whatever you may call it. We must show on our small data, what do we have? Like, what are the given variables? What are the unknown variables? But at this point, we know time is not what we have because time is what we should calculate for now. So Mara, you can see go 4.1.2. They want us also to calculate the distance covered by car A. So now we're looking at the information for car A only. What do we have on car A? According to the information given, so for car A, we are given the initial velocity of 15 meters per second. We know that it comes to rest and then it stops at 0 meters per second. And then we are given the acceleration, which is when they apply the brake. So it's decelerating. So it's 4.5 meters per second squared. They want us to calculate the time, and we also don't know the distance covered at that moment, right? So for now, I believe you know your equations of motions. It's just a matter of selecting which one to use from here. Having acceleration, initial velocity, and final velocity, I think the optional one at this moment from this, it would be this one. So the equation that I've selected is V final is equals to V initial plus AT, because I have the initial velocity, I have final velocity, and I have the acceleration. I just want to calculate the time. But like I said, I should practice what I said because, I should practice what I preach because I said you must always put the variable you want to calculate as the subject of the formula first before you substitute everything. So VF minus, when I take this one to the other side, is going to be minus VI is equals to AT, and then I divide by A both sides. Therefore, this will cancel that. Therefore, T is going to be V final minus V initial. V final minus V initial all over A. And then from here, it is in terms of T. T is the subject of the formula. And then I can substitute now. My VF is 0. 0 minus my initial velocity is 15 meters per second. And then the acceleration is minus 4.5 meters per second squared. If you punch this on your calculator, you will get that the value for T is the value for T is 3.33 seconds. So we can say car A stopped after 3.33 seconds when the driver applied the brakes. So 4.2.1, the answer is it took 3.33 seconds for the car to stop. 4.2.2, they want us to calculate the stopping distance of car A. Like how long did it travel before it stopped? Still talking about car A now. We still have the same information. Now we just want to know the distance now. Again, having my new data, now I know T is equals to 3.333. To calculate the changing distance, I could use this formula. Or I can use this formula. So to calculate the changing distance, I can either use this formula or this formula. This one would be correct because I found my T to be 3.33. But then I would advise you, here's the thing. From the two equations that I have, I would advise you that it's much easier to select the equation that can cover the given variables if you can avoid to use your previous answer on your next calculation. However, if you can't find a way, then it's fine. You can use the answer that you got from previous answer. But every time, whenever you are applying equations of motions or any situation where you have like multiple equations that look alike, it's easier to always go for the equation that has the variables that are given that you don't use the answer you got from your previous answer. Like for instance, if I use the top one here, yes, I do have the initial velocity is 0. I do have the acceleration is minus 4.5. T, I did calculate T is 3.3.3. I can substitute T there. But just because I want to avoid using my previous answer confidently, if I use this one, I can also get the distance because I have the final velocity, I have the initial velocity. I also have the acceleration. So my choice of equation for this one, it's going to be this for 2.2.2. So I think maybe it's it's wiser to show that 4.2.2 we have VF squared it's equals to VU squared plus 2A change in X. Now I want to make change in X subject of the formula because that's what I want to calculate. So here I will have VF squared minus VU squared is equals to 2AS change in X. That's if I take this one to the other side of the equal sign. And then because I want to calculate change in X, I will divide by 2A both sides. Then this will cancel that. Therefore, change in X is going to be VF squared minus VI squared all over 2A. Therefore, I can substitute now. My final velocity is 0 squared minus the initial velocity is 15 meters per second squared all over 2 minus 4.5 meters per second squared. Then what's left now is just to punch this on your calculator. If you punch this on the calculator, the answer that we will get is gonna be 25 meters. So after car A and car B has realized that there's an obstruction in front, the moment car A applies the brake and the car accelerated by minus 4.5 seconds, it took 3.33 seconds for the car to stop. And at that 3.3 seconds, the car traveled for 25 meters before it stops. Therefore, the distance covered by car A is 25 meters before it stopped. Now, coming to the real things. Question 4.3, you can see it's even 6 marks, meaning it's more juicier, meaning one has to work a bit harder. Here, they want you to, actually, they're saying which car, A or B, has the longest stopping distance. Support the answer with a calculation. Which car has the longest stopping distance? Already we know that the stopping distance for car A is 25 meters. We just have to calculate the stopping distance for car B and compare if the stopping distance for car A is longer than the stopping distance for car B. As simple as that. So now let's get the information we have about car B now. So the information we have for car B, the acceleration is the same. They're both accelerating at 4.5 meters per second squared. So the acceleration of car A and car B are both the same. But the initial velocity for car B, it was 30 meters per second. But it also comes to rest after they apply the brakes. So the final velocity, they both have to stop. So the final velocity is the same. We don't know the time, but now they want to know between car A and car B, which one had the longest stopping time. At this point, we know that for car A, the stopping time for car A change in X, it was 25 meters. So now that we know that for car A, the change in X is equals to 25 meters, we just have to calculate the change in X for car B and compare which one took the longest to stop. So again, to calculate that from my choices of equations of motions, I chose V squared, VF squared, it's equals to VI squared plus 2A change in X. Already we know that if I make change in X subject of the formula here, we'll get VF squared minus VI squared all over 2A. And then I can substitute from here. My final velocity is 0 minus my initial velocity is 30 meters per second for car B. And then my acceleration is the same, minus 4.5 meters per second squared. And if you punch this on your calculator, you'll find that the distance covered for car B is 100 meters when you punch this in the calculator. So for car B, it's going to be 100 meters there. So car A is 25 meters, car B is 100 meters, meaning you can write down like car B has the longest stopping time, like that. You can write it in weights. That's how you get your final mark to get your full 6 marks. And by looking at this, you can see that the one that has the highest velocity took longer to stop, which answers the next question, 4.4. 4.4, the question is they want to know what conclusion can be made about the relationship between speed and stopping distance. So a car that was traveling at a higher speed covered a long stopping distance. So we can say the higher the speed, the longer the distance of the stopping time, something like that. You can put it in your proper English there, but then that's the analogy of the mathematic part of it. I think for today we can stop here for the no, anyway, we're done with this one. So until we do the next video, we're gonna continue from there. Otherwise, I'm Mastermind Money. This is Simplified RSA, the guys who makes it looks easy. Please subscribe on our YouTube channel, follow us on Facebook, follow us on Instagram, on X, as well as on TikTok, and comment on our videos as well. Yeah, until we do the next one again.